What's up, bozos? Here we go. Day 2 notes, intro to angles. Let's get into this, okay? So this is probably the next part after your warm-up in that little packet of worksheets to do, okay? So just a heads up. Here's the notes. They're going to be nice and they'll be decent. They're going to be decent notes. And then there's going to be 2 worksheets that you guys are going to work on. It says arcs from central angles and arcs from inscribed angles. That'll be the classwork you have to do along with the homework. So just a heads up that you have those things done also. Okay, so without further ado, let's do intro to angles. Okay, so the first type of angle that we're going to talk about is angle ABC in this picture. So angle ABC in this picture is this angle right there. Okay, angle ABC is a central angle. Okay, so if you really think about it, it's at the center of a circle. It has to be at the center. So a central angle is always going to be connected to the center to make that angle. Okay, and in this case, the central angle ABC is 50 degrees. Okay, so the beautiful thing about central angles is that they're the most basic one because they're always the same as the arc that they make. Okay, so I know this degree of the central angle is going to be 50 degrees because the arc's degree was also 50 degrees. So these ones are definitely the best. Always the same as the arc it makes. Okay, so pretty basic stuff. So whenever you see it at the center, you could say, okay, that homie is the same as this and vice versa. Okay, beautiful. Next up is a little more tricky angle, okay? So this one's talking about angle DEF. So angle DEF is this little guy right here, okay? And so DEF is called an inscribed angle, okay? The inscribed angle has a little different quality than a central angle, okay? So one thing you notice about inscribed angles is that this homie's bouncing off the side, okay? So inscribed angles are always going to bounce off the side. Okay, it's not going to be inside anywhere else. It's going to just boom, like you just like shot a little laser pointer and it's just bouncing off the side. Okay, but the inscribed angle is actually half of the arc that it makes. So if this arc over here is 140 degrees, this will be 70. Okay, so inscribed angles are always half of the arc that they make. All right, so those are the 2 arcs that we're going to be talking about today, the central angle and the inscribed angle. Okay, really not a lot of work, is that central is the same as this, inscribed is half of the arc. Okay, gorgeous. So let's go on to some examples. Okay, down below we got basic examples, right? This is just like me. I'm super basic, okay? Angle LNM, so angle LNM is 28 degrees. So that's right there. Okay, hopefully you guys can see that. That's 28 degrees, okay? And then it wants me to find the measurement of arc LM. So arc LM is this here, okay? So the main thing to say here is that, okay, the angle that I'm giving you here, that is an inscribed angle because it's bouncing off the side. So this is inscribed. Okay, and since I know it's inscribed, I know this is half of whatever this is. So that would mean LM, that arc there, is 56 degrees. Okay, because 28 times 2, 56. All right, beautiful. Okay, next up we have circle T, and it says angle PTS. Okay, this little guy right here, it's 48 degrees. All right, that's 48. And then it's actually asking me something a little different here. It wants me to find arc RP. Okay, so we got to think a little differently here, especially in this one. Let's see if I can zoom in. Ooh, that's cute. Oh, cool. Wow. Okay. So here's the idea here. Angle PTS is a central angle because it's going through the center, right? Bounces off the center. So what I know here is that if this angle is 48 degrees, arc PS okay, which is not what we're looking for, but it'll help us, is also going to be 48 degrees, okay? So that's a piece of what I can find, but they want me to find what arc RP is. But remember, the diameter is your homie here because the diameter cuts a circle into half. And we know half of a circle is 180 degrees. Okay, that's the big key here. So that means arc RP is 132 degrees. Because if you remember, this is sup with the other angle, supplementary. Okay, and we'll be able to find that pretty smooth and beautifully. Okay, and if you want to even do a different way of finding it, if you know this angle is 48, then this central angle here is 132. And that's another way to find that arc. So do either way. Whatever you feel Gucci with, I am Gucci with. Let's take a little pause. I got a minion of the day that I got to do. You think I forget about these things. So my minion of the day, I don't really have them here because those homies are chilling at school. But I got Mr. Fantastic. Look at that. Look at that. That's fantastic. That's for you guys. It's the best I could do. Can't really do much. Let's keep going. Okay. Next up, we have example number tree. Okay, this guy over here. So they're not really giving me much. They want me to find angle BAC. So angle BAC is going to be this angle in here. Okay, let's use a different color. Okay, BAC. So it wants me to find this angle. Okay, so there's a few ways to think about this, but the easiest and smoothest way is to say, okay, look at the outside. On the outside of my circle, I have this arc is 71 degrees, this arc is 155 degrees. You should know that a full circle adds up to 360. So if I take my handy dandy calculator and I do 360 minus 155 minus 71, that will give me the remaining arc on this side, because that's the only thing I could really find. And that will be 134 degrees out here. Okay, so I know that arc is 134. That is the only thing you guys can find to start. Okay? And then, let's see if you guys can all answer this at the same time. What is the name of this angle BAC? Inscribed. Oh my God, you guys are incredible. I hate myself for talking to myself. Okay, that's an inscribed angle. Okay, so if that angle is inscribed, we know this is half of whatever the arc it makes is. Okay, and again, if you ever need a little visualization on what that looks like, if that angle expanded out like this, okay, it makes this arc. So sometimes I like to use my highlighters to kind of show, like, what are you really talking about, Mr. A? Well, I'm talking about that angle is going to make that arc. Okay. And since that angle is half of 134, that angle is going to be 67 degrees. Okay, because half of 134 is 67. Okay, any questions? Really? Oh my gosh, that's incredible. You guys usually have so many questions. This is so weird. Okay, let's go to the back. Let's go to the back. Okay. And on the back, there are some deeper examples. All right. So just a heads up, guys. I know I'm going to post something soon to kind of let you guys know, but the work that we're doing, if you have any questions, you guys could always email me from 9 a.m. to noon. And if you guys want to do a Zoom call, so like a video conference where you just ask me questions, that's totally cool with me. But you guys got to let me know if you're down for that, and we could totally do that, and I could go over homework questions, these questions, blah, blah, blah. But that's up to you guys. I will leave that up to you guys, but I'm more than willing to help you guys out on that. Okay, beautiful. Next up, deep examples, number 1. Okay, so with this deep example, why this is so weird. I don't like that. Let's do shallow, because shallow is even worse than being deep. Ooh, I don't like that. Okay, let's see what they want. They want, they give me circle S, and the measurement of angle SOX, and SOX are the worst, is 40 degrees. So SOX, okay, this is 40 degrees. All right, that's all they give us. Okay, and so we're expected to kind of go from here and find everything else. So it's actually not as bad as you think, because you have to just use some ideas that we've talked about in the last couple months. But the first idea is to find anything else. We need to first look at what they give us in the triangle. SO right here is a radius, right? It goes from the center to the outside. And SX is also a radius that goes from the center to the outside. So if you have a radius and a radius, that means that they are congruent to each other. Because if you have one radius in a circle, the other radius is going to be the same. So by further ado, if we want angle SXO, which is this angle here, we have made a tiny isosceles triangle. So if this angle is 40, this angle is also 40 degrees. Okay? But again, you got to kind of look at that. You got to really think about that. Okay? And then from there, this will really open up everything for us to be able to find. Okay? Because next up, they want us to find angle OSX. So OSX, that is this angle up in here. But you guys should understand that this is a triangle right over here. And triangles add up to what? 180. Okay, wow, 180. Cool. So that means this angle is 100. 100 degrees. Because again, 100 plus 40 is 180, which is what a triangle is. Okay? And from this point on, we're basically rolling through this puppy because next they want the measure of arc OX. Again, think basketball shot arc. Arc OX goes from O to X like this. Okay? And if you think in terms of what we just talked about in the last page, is that this angle here is a central angle from a center. So if this is 100, that means this, oops, excuse me, burped again. This arc is also 100 degrees. Can you see that? No? Okay, sorry. That's 100 degrees. So the measure of arc OX is 100 degrees also. Okay? And then last but not least, hopefully you guys can find this from here, is that angle OFX, so that's this angle up in here, that angle is an inscribed angle. So this is always half of whatever the arc it makes is. And again, if you're always worried about like, hey, what arc does this make, whatever, if you shoot out the sides of that angle, it's going to make whatever connects it. So it's making that arc. So if this is 100, that means that this has to be 50 cent. Okay, that's what this angle is. Okay, and you've used central and inscribed angles. Beautiful, gorgeous, hot? No, don't say hot. Lukewarm? Beautiful. Okay, let's keep going. And again, if you guys feel at any time you want to just like turn this off and just do the problems yourself, that's totally Gucci with me, bro. Totally Gucci with me. Okay. Oh, nice and easy. So super nice and easy. You guys could totally do this one. You guys are rock stars. They're giving me the arc. You guys got that. Boom, boom, boom. Bada bing, bada boom. I trust you. Okay, you got that. Over here, this, don't worry too much about it. This is like the fancy mathy way that math nerds talk about math things with stuff like that. I don't know what I'm trying to say. But anyways, if I look at this picture here, the measure of angle HWK, hawk. So this angle here. Okay, that's that angle. This we'll do the blue here. And then we'll do nice pretty pink for angle HAK, which is over here. So that's this. Okay, so if you kind of understand the relationship between central angles and inscribed angles, it can kind of help you out with things going a little further from there. So if you look at this picture, this little central angle, right, if it shoots out, that makes that arc, right? So I know this angle is going to make that arc versus my other angle over here. Let's get another color. My other angle HAK is also making the same arc. So the central and inscribed are both making the same arc HK. So if you think about a relationship you could create in a more conceptual way, is that the measurement of angle HWK is 2 times whatever angle HAK is. Because again, if this angle is 100, for example, that means this is 100, and that angle is 50. So 2 50s make 100. And vice versa, this is always going to be half of whatever this is. So it's half of measurement angle HW. Okay. Don't worry too much about this. This is just a conceptual idea showing that when central and inscribed make the same arc, what are they going to look like? And you got it. Okay? So last but not least, before we get into other things, is this final example here. So it looks crazy. It looks like a fancy design. Promise you it's one of the easiest problems that we could do. And it tells me that arc AC is 50. So that's all they give me. That's it. That homie's 50. That's it. And they want me to find angle ABC, angle ADC, AEC, AFC, all these things. Okay? Why didn't they do NFC? It's kind of weird. That's pretty uninclusive for the NFL. But again, very simple. And the reason I'll tell you that is this. If you look at angle ABC, that's this cute little angle here. That angle, if we extend out the sides, okay, like that, it makes arc AC. So because ABC is an inscribed angle making 50 degrees, that means angle ABC is 25 degrees. It's half. Okay? Because again, we're working with a bunch of inscribed angles. Okay? These inscribed angles are going to be half of whatever arc that they make. Okay? And if you keep using that idea here, let's look at angle ADC. ADC is this angle here. But if you think in terms of what I was telling you earlier about, imagine the angle is expanding open. That angle is also making arc AC if you expand it. So by the same idea, this is always half of the arc it makes because it's inscribed. So angle ADC is 25 degrees. And if I keep repeating that procedure, again, here's my angle, but it opens up to the same thing. That's also 25, and this is also 25. Okay, so that is how we find that all. It is gorgeous and beautiful, just like me. I hope you guys enjoyed. The next thing up are going to be these other two worksheets. I'm going to go through a few examples and then leave the rest to you guys. But basically, this should really help you out on all that stuff. So peace, homies. One more video to come. Ciao, ciao.